periodic table, there is another element that's 2 steps forward by the name of plutonium. Uranium can be found in nature, but you can't find plutonium in nature because it's man-made. When you look at the table of elements, you see different elements that have been discovered in this year or that year. But plutonium wasn't discovered, but it was made in 1940. What does plutonium even look like? This is how it looks like. Silver like a lot of other metals, but extremely dangerous. One of the reasons is that it's used in nuclear weapons, and the other reason that it's extremely radioactive. And it is also known as one of the most radioactive metals on Earth. When they were building the first nuclear weapons in Los Alamos, New Mexico, basically the Manhattan Project, which we made a video about, they were making plutonium to put in the atomic bomb. They knew that this metal is extremely radioactive, and they would work on them in those laboratory glove boxes. But unfortunately, one day one scientist was working on plutonium, but his glove had a little hole, and a tiny amount of plutonium touched his hand, and he immediately pulls out his hand. He gets very stressed and worries that he touched plutonium and it's all over. When the doctors ran some tests, they noticed that the plutonium is in his blood, but he didn't get sick because you weren't exposed to it for long. Throughout his life, he would always give blood tests to make sure he's not sick or has cancer. But in all tests, plutonium was found in his blood, but he never got sick. The plutonium, even 50 years after the incident, was still in his blood. But the doctors believe that if he was exposed a little bit longer, he would have gone sick or had cancer and would have died way sooner than 50 years. But the amount was minimal and it didn't bother. Poor guy was stressed all his life because of this. How is plutonium even made? You guys know those fuel rods in a nuclear reactor, right? We talked about them in our uranium video. The plutonium comes from the nuclear reactor rods. As you guys know, uranium's atomic number is 92, and uranium turns into plutonium, which has an atomic number of 94. But the uranium that turns into plutonium is uranium-238. If we want to put it in simple terms, it's basically uranium-238 capturing neutron and turning into plutonium-239. Plutonium is a very dense and hard metal. Machining this type of metal is extremely hard because it's such a stiff metal that it breaks easily. And to create nuclear weapons, it has to be machined, and they use it to create a sphere of plutonium for the atomic bombs. This metal with this high of a density melts very quickly, so the melting point is very low. 639 degrees Celsius to be exact, and for a metal with this type of density, it's extremely low. Let's compare it to iridium, one of the densest metal in the world, but its melting point is 2446 degrees centigrade. So plutonium is extremely weak towards heat. As you guys know, we talked about osmium in our iridium video. Iridium is very dense, but osmium is a little bit more dense. Osmium's melting point is more than 3000 degrees centigrade. But let's get back to plutonium. Plutonium is so radioactive that it literally gives off heat. You're not supposed to touch it, but if you were to touch it, you would feel a hot piece of metal. When plutonium starts to decay, it gives off helium. So if there is an old piece of plutonium in a container, there will be helium gas around it. And when it's giving off helium, it's basically making the metal weaker and weaker. You could kind of compare it to metal rusting. And that is why when plutonium is used in places like this, they have to make sure it's perfect. Another thing that makes plutonium extremely dangerous is dealing with plutonium waste. To do this, there has to be a specific container that could handle a lot of pressure. If it's not like that, it will explode. As you remember, plutonium gives off helium, and it creates pressure in a container. If the walls of a container is weak, it will blow it up, and radioactive waste will go everywhere. Alphimatic, a UK chemist, was working on the atomic bomb during World War II, and at that time, he only had access to about 10 milligrams of plutonium. And unfortunately, he spills that 10 milligrams of plutonium on the desk. Obviously, he gets bummed out. Not because there's dangerous material on his desk, but he wasted all the plutonium they had access to, and they needed it for the bomb. How is he gonna collect it back? He immediately brings a handsaw and cuts the table around the plutonium, and he puts it in a furnace. He puts a container underneath it and sets it on fire. He basically burned the wood so the plutonium gets separated from the wood. He separated the ash, and he once again had the plutonium he needed. By doing this, he loses half a milligram of plutonium, so he had about 9.5 milligrams left. The science lab realized what he has done, but they didn't do anything with him, and they understood that he had to do that. It's good to know that when they're working